Students, welcome to my YouTube channel. In this video lecture, we are going to look at some 8-9 quiz questions related to human factors topic. Very important, these human factors are relevant to when we start applying, when we do flying, especially in night conditions, low visibility conditions. So let's look at some human factors question which may influence our performance. First, question number 1. What is the most effective way to use eyes during night flying? Okay, so the first, look only far away at dim lights, scan slowly to permit off-center viewing, meaning use your peripheral vision, concentrate directly on each object for a few seconds. So correct option is option number brown. At night flying, you should always use your peripheral vision because at night flying, you use the rods. Okay, there are rods and cones in your eyes. So rods are useful at night time. Okay, and these rods are not situated directly at the retina. They are situated or located at the periphery of our eyes, and therefore it is suggested that we use peripheral vision during night flight. Okay, so scan slowly to permit off center viewing. So that's why this is the correct option. Next, the best method to use when looking for other traffic at night is to do what? So you're looking for other traffic. Look at the side of the object and scan slowly. Scan the visual field very rapidly. So this is wrong. You have to do slow scan. Okay. Next, look to the side of the object and scan rapidly. Again, you should not scan rapidly because it is night time. So option C is also wrong. The correct option is option A. Look to the side of the object, meaning use your peripheral vision and scan slowly. Next, question number 3. The most effective method of scanning for other aircraft for collision avoidance during night hours is to use what? Regularly spaced concentration on the 3 o'clock, 9 o'clock, 12 o'clock positions. That is wrong. You have to place this angles, that is 3 o'clock, 9 o'clock, 12 o'clock, are wrong. You have to space your concentration in 10-degree angles, not 30 degree, 10 degree. Next, a series of short, regularly spaced eye movements to search each 30-degree sector, peripheral vision by scanning small sectors and utilizing off-center viewing. So again, option C is right and option Bravo is wrong because it's not a 30-degree sector, it's a 10-degree sector. Okay, small sector. So at night time, peripheral vision must be used. You should scan small sectors 10 degree measurement and utilize off center viewing. Question number 4. During a night flight, you observe a steady red light and a flashing red light ahead and at the same altitude. So it's a night flight and you observe a steady red light and a flashing red light ahead, that is in front of you. What is the general direction of movement of the other aircraft? What is the direction of movement of the traffic? So look, let's say this is your north data, okay, and this is one aircraft flying north, flying north, okay, flies north. Now there is something called navigation lights, right? So there are navigation lights located on your aircraft. So there is a red navigation light on the left wingtip. There is a green navigation light on the right wingtip, and then there is a white navigation light. I'll use the color blue for it. There is a white color navigation light at the rear of the fuselage. So these three are called navigation lights. In addition to this, there is always a beacon light on the tail of aircraft, which is a flashing light. Okay, navigation lights are steady lights. Navigation lights navigation lights, nav lights are steady lights. This beacon or anti-collision light will be flashing lights. Okay, so this is the location, or these are the positions of navigation lights and anti-collision or beacon. Now, in this question, they have told you that you are able to see the steady red light and a flashing red light. That means you are able to see this steady red light, which is steady red navigation light, and flashing red light of aircraft which is in front of you. Okay, so let's say this is your position. This is your position, and you are flying northerly direction. And there is an aircraft in front of you like this. Okay, and you are able to spot red navigation light. That means you are able to spot navigation light. That means you are able to spot left wing of this aircraft, and that is only possible when aircraft or the traffic in front of you is flying from right hand side to left hand side. In that case, you will be able to see the left wing of that aircraft. You will be able to see the left wing of that aircraft, not the right wing. Okay, and that's why the red navigation light. That's why the red navigation light, this one. And beacon, which is a flashing red light, it will be on the top of the tail section of this aircraft, so that is also visible to you. So the correct option will be the traffic is crossing to the left, the traffic or aircraft crossing to the right hand side, the traffic is approaching head on. So correct option is option number A. This traffic that is in front of you is crossing to the left hand side. From the right hand side, that is from the easterly direction to westerly direction, or going to your left hand side. Next, during a night flight, you observe a steady white light and a flashing red light ahead and at the same altitude. Now, in this case, you are able to observe a steady white light. Steady white light, that means they are talking about navigation light. They are talking about navigation light. And a flashing red light also. Flashing red light, that means they are talking about beacon. Okay. Ahead and at the same altitude. What is the direction of movement of the other aircraft? Now we will use this same picture. Now there is red navigation light on the left wing, green light on the right, white navigation light on the rear of the fuselage, a red flashing light beacon anti-collision light on the top of the fuselage. Now in the question here you are able to see a white light and red light, flashing red light. So you will be able to see white light only and only when you are behind this aircraft, right? Only and only when you are behind this aircraft, flying straight ahead, flying in the northerly direction, or behind this aircraft, and both of you are flying in the same direction, that is north. Okay, only in that case you will be able to see the white light, because that white light is situated behind this aircraft. Correct? Uh, White light. Red and green will not be visible to you because this red navigation light and green navigation light are directed forward, are directed forward. Whereas this white navigation light, is directed backward, and red and green navigation lights are directed forward. So that's why if you are behind this aircraft, flying in the same direction as this aircraft, you will be only able to see this white light and the beacon light on the top of the fuselage. So the correct answer here will be the other aircraft is flying away from you, the other aircraft is crossing to the left hand side, it is crossing to the right hand side. So correct option is option A. The other aircraft, that is this traffic, is flying away from us. Okay, it's not coming towards us, it is not going to the left or right, it is going away from us. So another very important question. Next, question number 6. VFR approaches to land at night should be accomplished at faster speeds with a steeper descent or glide slope, the same as during daytime. So very important practical question. So whenever you are conducting a VFR approach at night time, all your all the planning, your descent should be the same, descent airspeed should be the same as that during daytime. Okay, during daytime. So correct option will be option C. VFR approaches to land at night should be accomplished the same way you accomplished VFR approaches at daytime. Okay, next. Question 7. What preparation should a pilot make to adapt? Adapt means to adjust the eyes for night flying. Very important. Another practical question. Wear sunglasses after sunset until ready for flight. Wrong. Avoid red lights at least 30 minutes before the flight. Yes, but this is not the perfect solution. Avoid bright white lights at least 30 minutes before the flight. So option C is wrong actually. Option B, option B is wrong, and option C is right. Okay, option C is the right answer. So you have to avoid bright color, white, yellow lights at least 30 minutes before your night flying starts. And avoid red lights. Option Bravo is wrong. Actually, in reality, red lights help you adjust to night flying conditions quickly, easily. Okay, so that's why whenever we are flying or doing a night flight, we always use red color headlights or torches so that to look at the instruments, etc. We do not use bright white color lights to check the instruments for instrument scanning, for reading maps, etc. So always use red lights, okay, flashlights, and so it is. You should avoid white lights. Do not avoid red lights. Red lights are actually helpful to accustom your eyes to night flying conditions. Okay, so option B is wrong. Option C is right. You should avoid white lights and prefer red lights. Question number 8. If a pilot experiences spatial disorientation, now what is spatial disorientation? This is nothing but in simple words, confusion in the brain. This is the instruments. The system is telling you, is giving you one kind of information, and your body, your sensory organs are giving you some other information. So there is mismatch. Okay, so there is confusion in the brain. This is nothing but your spatial disorientation. So if a pilot experiences this confusion during flight in a restricted visibility condition, poor visibility condition, the best way to overcome this effect is to do what? Rely upon aircraft instrument indications, concentrate on yaw, pitch and roll sensations, consciously slow the breathing rate until symptoms clear and then resume normal breathing rate. So correct option is option A. Always trust your instruments. Do not listen to your body sensations. Okay, so option Bravo will be wrong. Option C is wrong because this relates to hyperventilation, not spatial disorientation. Okay. Pilots are more subject or more likely to get spatial disorientation if they ignore the sensations of muscles and inner ear. Body signals are used to interpret flight attitude. Eyes are moved often in the process of cross-checking the flight instruments. So you are subject to spatial disorientation if you listen to your body signals. Body signals. Okay. Ignoring the sensations of the body signals, uh, cross-checking the flight instruments, these two are remedies, okay, solutions to this problem, not the problem themselves, okay. So ignore the sensation of muscles and inner ear to avoid spatial disorientation or to curtail spatial disorientation, and move your eyes so as to cross-check flight instruments, interpret that information and control your aircraft. But do not listen to your body signals. If you do that, if you rely on your body signals or sensations to control your aircraft, you will get spatial disorientation, confusion in the brain. So option B is the correct option. With this, we conclude this lecture. I hope you have understood these 9 questions, their answers, the explanations. I hope you learned something new today as well. And I request you all to keep practicing human factors questions from different air regulations book. There are many human books based on human factors itself. Okay, so it's very important topic for aviation safety. I request you to subscribe to this channel, share this video with your friends. All the best.